Generating resource states, which are small clusters of entangled photons, is the heart of photonic quantum computing. However, generating even small photonic clusters turns out to be a huge challenge. Current approaches use probabilistic protocols with low success rates of each attempt, resulting in complex R.S.Gs that force the computer to occupy the space of an entire factory floor. In Quantum Source, we harness our cutting-edge proprietary technology of photon atom gates to make the entire resource state generation deterministic, thereby enabling the construction of powerful, practical, and cost-efficient photonic quantum computers. The core of our R.S.G is a small vacuum cell in which a cloud of slow rubidium atoms is held by laser beams. Narrow laser beams are delivering atoms to be trapped at designated sites on a photonic chip that is located on the top of the vacuum cell. Single rubidium atoms are laser trapped near high-quality optical micro-ring resonators on the photonic chip, with each atom just 100 nanometers from the surface. Repeated excitation pulses from an external laser beam turn the trapped atom to a deterministic single photon gun, emitting single photon pulses into the optical resonator and from there to the output waveguide. The photon is then directed to the next part on the chip, which is designed to entangle the photons with each other to create the desired cluster state. This part is essentially a photonic switch controlled by a single atom. It is composed from two beam splitters, with a second trapped atom in between. The state of the atom controls to which output waveguide the photons will be directed. The atom state is initially set to be determined by the first photon. Since the photon may or may not pass through the upper waveguide, the atom is now at a superposition state. After that, the atom will be set to direct all the consecutive photons to either the upper output, 0, or to the lower, 1, depending on its state. Since the atom was set to a superposition state, that results in an entangled cluster state. All the photons are in an unknown qubit state, 0 or 1, but together. This way, this atom acts like the needle in a sewing machine, stitching all the photons together. By changing the photonic and atomic configurations, we can generate a host of different cluster states, enabling the most efficient route for the weaving of the error correction fabric. With Quantum Source's breakthrough technology, we're not just dreaming about million-qubit computations, we're putting them within arm's reach.